seen that
Okay,
before.
so this is our November structural modeling video conference. We have addressing some challenges with the new moving of Google Hangouts Plus to YouTube, but I think everyone is getting the idea of how to make things work. I might take a few more months or tries at this to get it all ironed out, but essentially we're moving forward. And so today we have Kevin and Yanis that I think they're like in Cyprus, and Kevin's going to be talking about his response to last month's notes and where things are going, and also their latest research and what they've been doing the last month. So with that, Kevin, take it away.
Kevin, forgive me for breaking in for a moment, but I wanted to mention two things. One, Peter Tuddenham has joined us, and we can actually see him through the interface that at least I am using.
Yeah.
Gives you some information. Now I'll get off.
Right.
Hi, Peter. Okay, Kevin, take it away.
You have to turn this on.
Yeah. Oh, this. Turning it off.
Okay.
Well, since I'm here with Yanis Lauris, maybe we could just mention some of the work we're doing with ISM and software that uses ISM.
That's great.
Maybe there's two technologies here that Yanis has been working on. One is an upgrade to the Christakis software called Cognoscope, and he created a version 3 of the Cognoscope. Now, the lineage of this is when Warfield was working on the algorithm back in the 70s, they contracted with people at the University of Dayton, and then there was a series of companies that got involved in coding the ISM, including UNIVAC, IBM, NASA, and Dayton, University of Dayton. And at one of these, Christakis picked up on one of these when he was when they moved from Ohio to the University of Virginia, and he started working on it on his own. And it became called the Cognoscope 1 in the 1989, 1990. And then after I joined him, he started working on Cognoscope 2 based on recommendations I was making for requirements. And that went on for another decade. And then, how long ago did you get involved with it, Yanis?
If I remember correctly, we have done a global structured democratic dialogue virtually. That was 2010 when we did that dialogue, in which members of the Agoras, both scientists and practitioners, participated in proposing requirements for an upgrade. And then we used ISM to structure these requirements so that we could figure out which ones would be the most influential, so that we would give priority to them. A year later, Christakis donated the code to Future Word Center, and my programmers started since then to work on upgrading Cognoscope 2 to a version we call Cognoscope 3 Classic, which includes many of those requirements that the Agoras community wished. We did also another kind of technical upgrade, in the sense that the new version, Cognoscope 3, runs not only on Windows computers, but also on Macintosh computers. We didn't change anything in the ISM algorithm inside. We changed a lot in the periphery of the software and the way the data is being calculated and presented. But the ISM algorithm is intact, And now that Kevin was in Cyprus, we went through that algorithm together.
Along with the Patel monograph from Warfield.
Yes, to check and discover deviations from the Warfield algorithm, up to the point that we have investigated the algorithm. We didn't find any deviation from Warfield's writings, but we didn't finish our work. We will continue in the early next year, because we didn't consider yet the part of the algorithm which is called the opportunity matrix, which calculates the next question to show to the participants in an intelligent way that would minimize the number of total questions to be asked. And I know from previously, when I was designing ISM for other platforms, when I looked at the Christakis algorithm, that there are 2 or 3 different ways of calculating this matrix, and they don't have the same result. The number of questions needed to conclude the ISM is different. It's not a big difference, it's about 10% different. What we want to really investigate deeper is whether the final 3 will be different. That would be interesting to investigate. Now I will not be able yet to give any information based on what we did with Kevin here, whether they produce a really different result. But in February, hopefully, if Kevin comes again here, we will continue this investigation and we will know that.
I just mentioned one thing I mentioned on our next phase of work on understanding how the opportunity matrix is calculated is that these days the great majority, if not like 95% of publications that are using the term interpretive structural modeling do not use the opportunity matrix. They don't save anything in filling in the matrix. They're just using a portion of ISM, which is to find the hierarchy from a fully filled in adjacency matrix. This is, almost all, I think all of the papers I've seen from India just totally ignore the efficiency side. Now, I know, Joe, you produced some graphs on how after a threshold, the efficiency of the inquiry goes way up.
Yes.
Could you talk a little bit about that? Because that gives us a context for our work on the opportunity matrix.
Sure. That's essentially, there's partitioned the relationship types. So the way that we view this is we view this as a translation from informal natural language relationships. We're translating those informal natural language relationships mathematical relations. And we developed the AMEI, the Augmented Model Exchange Isomorphism, to allow us to classify the logical properties associated with the natural language structuring relationships. And then that gives us a key to actually applying the right type of transform to transform it to the mathematical relation. And so the graphics talking about then is associated with a specific type of natural language relationship that has a irreflexive, asymmetric, and transitive logical property group. So when we look at our applications, the first thing we need to do, which of these logical property groups the natural language structuring relationship is associated with. Once we know that, then we can pick the right algorithm to use. So when we looked at the north of city structure, that was process by which we were using a logical property group to select the type of mathematical relation, and it's very efficient. Logical property groups where it is not as efficient. And so there's a wide range, and what you see in the software that we're developing now is that we actually have different approaches depending upon the logical property groups that are associated with the natural language relationship. So that makes sense?
So you were saying the priority structure in the north of relationship had it was very efficient in the number of inquiries compared to the total matrix, and other relationships it's not as efficient?
Well, I think some keys to understanding this is if you look at the appendix in the interactive management, where they discuss the GMU ISM software. They outline 3, I think, and in 2 of those commands, one is the clustering command and the other is the priority command. They talk about the efficiencies that are achieved within the software because of the logical inference that the computer can use. So that type of efficiency based on the logical inference is listed there in the handbook in that appendix. And so that's basically what we're doing. We're saying globally, we know certain logical relationships are about this type of structure. All types of structure are the same, and so to properly apply an efficient algorithm, then you need to understand that. You can do a general algorithm, I believe, that essentially allows you to do them all, but it's not very efficient. And that's one of the things that I'm thinking about and working on now and hope to get to in the next few months, is actually to look at that general algorithm. Really what we've been doing is we've been doing specialty types of algorithms that only fit in certain logical boxes, certain logical relationship groups.
Wow.
The logic, if I can insert something here, Joe,
Sure.
The logic of the opportunity matrix is by choosing among different options of the next question and calculating it. You could call it a success score. So if I choose this pair and I get a relationship, how many ones will I infer? So that my from the adjacency matrix, I get them in the reachability matrix. How many ones will I gain? If I make the other choice, how many? So it's like a chess calculation where you check your options and you choose the one with the possible maximum benefit.
Right. So the what I understand you talking about, Giannis, is basically what I believe Warfield was discussing in transitive embedding and scanning. And this is one of the issues in looking at this approach, because the work that was proof of concept that Warfield did essentially started with matrices that were filled out. Starting with matrices that are filled out. We're starting with empty matrices. So we need to have some process by which we go forward and make that initial data insertion into the matrix. And Warfield talks about that in the transitive embedding problem. And so he says, well, the first thing, there's a couple of ways to do it. One of them is the scanning method. And he details what his scanning method is. And then once you do the scanning method, then you split have filled in partially with the scan, and you make the two matrices. And then when you have the two matrices, you're able to start doing the transitive embedding, logical inference type of activities. About. So there's a preliminary step, the scanning part, and that is specifically what I've been looking at in these search algorithms. They're standard computer science search algorithms. They can be applied to situations where you're scanning and trying to order things. There's a lot of information, a lot of knowledge about how to do that efficiently. We have, and looking at and reproducing the work that was done in the appendix of the Handbook of Interactive Management, what I found is actually they were doing in one of the approaches, they were actually doing a binary search. And so that's what I've been looking at is, instead of doing a simple search, you can do a binary search during the scanning procedure. It doesn't really talk a lot about how you do a scanning procedure. I think there's a few sentences there. So does that make sense?
Yes, it makes complete sense. Let me explain how we implement the algorithm in our case. When you start with the empty matrix, the original choices of the questions to be asked are made based on the ideas that have received the most votes. So this is how you begin. The two ideas that have received the top votes by the participants will be the first two to be compared for influences. And then you take the next one, the next one, and the next one. So for a couple of questions, there are no inferences. I mean, there are still inferences, but there are not so many inferences that can be calculated. But this is how you start from the empty matrix and you get a partially filled matrix. Now, after you have a partially filled matrix, this is when the challenge begins on how to optimize that.
Yeah, so, and it appears to me that what I heard you explain was the bordering algorithm.
Yes, correct.
And so the bordering algorithm is a little bit different than the scanning. And so, and these are the concepts, I believe, back and looking specifically and reproducing the outputs from the Handbook on Interactive Management, and also looking at the other, that we can actually add a little more definition and the algorithms and exactly what these things are, fill that in a little bit, because there is some uncertainty there. And that's one of the reasons it's driving, this detailed approach, logical combinations, and to look at specific algorithms. But we can publish that, and then that can be discussed and looked at, and people can say whether or not they believe it's true, and then we can have some type of common, open, we can talk about it.
Yeah. Give some report because we have to leave.
Yeah, you're going to change?
We have to leave in 10
Okay.
minutes.
10 minutes. Okay.
Are
Yeah.
we good?
You want to go change?
Yes, I will go check.
Yeah. So, okay, so I'm going to, you see the email
I do.
on the screen? Okay, so the first thing I mention is you highlighted this fellow Gorvet's
Yes.
article or letter to the editor in Psychology magazine.
Well, he actually has a series of 9 articles that he's written. Yeah. Hogan.
Wow.
Michael Hogan.
Hogan, right, not Gorvet. Yeah, I came across an article on ISM that he did a couple years ago.
He seemed to work with Bloom, I think.
Broome out in Arizona?
Yeah.
Oh. What, could you give us a quick summary of what it's about?
Oh, sure. So basically he's working on he's very interested in individual freedom, digital democracy, and collective intelligence. His book is on critical thinking. He basically believes that the way that we're using computers and information management now is not helping human beings. It's actually overwhelming human beings. And we need to have a more robust, well thought out approach to managing large scale data, especially at the national and international level. His work with Bloom basically points out that Warfield's approach essentially is, he believes, is the key to actually dealing with this effectively by understanding the psychological and intellectual barriers and emotional barriers that humans and groups have. He's used that material to do, publish research on critical thinking, digital democracy, integrating, diverse groups of people. So that's basically it. I can send you some of his research papers.
Yeah, sure. I just mentioned I read through one of the articles that you had linked.
Yeah.
And he references this guy's name is Petit.
Okay.
He's in England, and his studies on freedom. And I just found it interesting that I've been following Petit's work on a new field he calls judgment aggregation.
Okay, good.
And judgment aggregation has been around less than a decade or so, and it's like a challenge to the whole field of social choice theory, which came out of Arrow's work. So judgment aggregation is like social choice theory with logic instead of statistics. And anyway, I just found it interesting that we're keying on the same person, but for different reasons. I never read anything of Petit's work on freedom.
All right, good. That's excellent.
I'm going to move through the other parts because we got to leave in shortly.
Hey.
You mentioned Warfield's modules that in what you were talking about. I was wondering if I don't remember using the DOS. I mean, I used the DOS model in the early 90s, and I think that that cycles could emerge from the do model in Warfield software. Cycles emerge from asymmetric relationships in the ISM software we're using now. So I was a little confused by what you were saying in the video.
Right. So that's really a good point. I didn't go into the details on that, but what I meant was the example that he used was weight, how things are heavy, what's heavier than A is heavier than B, B is heavier than C. Typically was the natural language structuring relationship that was used in that model, right?
Yeah.
It doesn't generate cycles because it's a global natural language relationship. So if you think about, weight, and the weight of all objects, it's basically is implemented by gravity, which is a global field, right?
Yeah.
And so we generate the concept of, we have a global acting natural language relationship. Now, if you think about influence, like the things that you people are focused on with your relationship is influence, that's local. A can influence B, B can influence C, but all those interactions are local between each other. There's no, everything doesn't count. And so when you have the same logical property set, the same three logical properties in the natural language relationship, and you have a local type of acting relationship, then it can generate cycles. But if you have a global natural language relationship with the same three logical properties in the group, then it does not create cycles. So that's just a way of saying, have the AMEI and we can talk about groups of logical properties, now we can go further and say, okay, we have logical properties, natural language relationships, some that create cycles, some that do not.
I think this distinction between global and local relationships, that's from you, right? I don't remember reading anything about that distinction before.
Well, yes, I think I made that up, but well, not really.
Yeah,
but
I think it's a good contribution.
It's a concept. It's a concept that we need to add. We need to add this concept so we can clearly communicate.
Right.
We did global and local terms in our papers on information density, and the way that we use the terms, I believe, are isomorphic. We did publish some papers where we used those terms before, but that was in metrics, for entropy metrics, physical entropy and information entropy, and I believe they translate directly to this context.
Yeah. Okay, I'm going to go through the other pieces. The adjacent, Warfield's use of the word adjacent is very problematic, and I think it's part of his confusion between talking about structures in general, specific structures, and relationships. And he uses the word adjacent in a spatial way, but then it has an overlap with adjacency matrix and things like that. And I just think anytime you see that word adjacent in Warfield's writings, you got to be aware that it's.
Yes.
The next thing I just mentioned, I did a course. I just completed a course with the Santa Fe Institute in New Mexico, the Complexity Sciences Institute.
Oh, excellent! Did you have fun?
Yeah, it was on agent-based modeling, so
Cool.
using a language called NetLogo, and I started working on an ISM algorithm that doesn't use matrices. It just uses graph search.
Uh-huh.
So it does transitive closure using graph search, and then transitive reduction using graph search. And what my interest in doing it is I'm looking for a way for every idea in the simulation to do its own processing. Like our current paradigm of doing ISM is there's a single matrix that processes everything that's interacting with it, which is usually just the answer to a pairwise question from a majority vote that goes in as a single yes or no. And what I'm interested in is a distributed algorithm that every idea does its own ISM in parallel with all the other ideas. And that can be done with matrices too. It can also be done with matrices where everybody has their own matrix to keep track of their own reachability. But you can use graph search instead of matrix algebra. So I just mentioned that.
That's excellent.
It's kind of a fun new thing. I think it's very publishable because there hasn't been a non-matrix approach to ISM published.
Good. Excellent.
Yeah. Could you talk a little bit about when you said you're using standard searching and sorting algorithms in the SMP?
Yeah. So there's basically, in searching and sorting algorithms are this fundamental staple of computer science, right? So essentially you have simple search, then you have binary search, you have bubble sort, you have searching and sorting routines. So when you're looking at and looking for a position, like when you're ordering things within the matrix, and these is a class of natural language relationships that these computer science algorithms apply to. Specifically, it applies to the ordering of the way things weight, the weight of things, which was the example out of the handbook, is that you can either compare each item together, right? Or once you have established the order of a subset of the items within your matrix. Then you can start doing a binary search or a modified binary search on the ones you've already ordered. Appears to me to be very, very similar to what Giannis was saying about the voting and the way that you start out. You start out with the top, take two, you go two more, but then you have problem once you get more items put together. So very specifically in the DoClass example that Moorfield published in the Handbook of Interactive Management, Appendix 2 in the back, it appears that when they're going through and comparing that they're actually doing a binary search on the ones because they ordered that part of the matrix. I'll work that up next and try to be more clear about it.
Okay. We have to go in a minute.
Okay.
And I want to just mention two things. One, I'm interested in working on the user interface requirements that you were requesting, but I need to kind of set up a one-on-one for you to walk me through how to do that.
Sure.
How to engage it. The other thing is, I think you opened up a very interesting discussion on the notion of scope.
Yeah, isn't that fun?
It is, and I did some previous work that suggested the need for that too. So, but we have to go now. So I'm gonna bid you adieu.
Thanks for taking the time. Have fun with Giannis and crew over there, and we'll talk with you
I
later.
apologize, I'm taking him away, but we arranged for a very nice dinner.
All right, gonna feed him before he leaves. All right.
Thank you.
Yeah, we got to feed him before he leaves.
Okay. Bye-bye.
Thank you
Take
both.
care.
See you.
Enjoy.
Janet, how you doing?
Hi. Yeah, actually, we just realized that our inner clock was off. We flew in from Florida late last night and then woke up with a start and realized that your call was going on. Anyway, Michael's here too, but we didn't get set up with both machines. We'll try to do that for next time.
No problem.
So doing fine. Wish we had heard more. I guess we'll catch up. Will this video be published or?
This is this video will be published. Yes.
Okay, so we'll catch up with that.
All right.
Yeah, so just getting back in the swing of things. The global-local distinction sounds interesting. What Kevin's doing with the agent-based graph search alternative is really interesting. This is something we've talked about with Peter. Exploring the similarities and differences between matrix approaches and graph search approaches. So it's great that he's getting into that. I was just trying to catch up with your paper there. Which one should I be looking at? Which of the read aheads?
It should be the one that's on 1031.
1031. Okay.
I have it on the screen now. So.
Okay, I should be able to find it.
Yeah, it should be it. Okay, good. Peter, how are you doing?
Yeah, good. Thank you. Yeah, fine. This is great stuff. Very interesting to see what's going on. We've been using, as Janet just said, we've been using some graph databases for some of the work we've been doing. So I'm very interested in how that idea. Yeah, I mean, and the other thing too is it would be good to think about how we might use whatever's currently current, or maybe you can steer me to, a version that could be used perhaps in some of the work that we are doing on systems literacy. I think it would be good to actually use the software. I mean, I have ISM from way back. and I'm not quite sure. I got a version way back when Warfield and Aleko were at George Mason, and then recently got a version because of work I'm doing in Europe with the Sea Change project, which is a European Horizon 2020 project, and Christine Donegan at the National University of Ireland in Galway is working with, I don't know his name, Professor Bloom.
Oh, yes, right.
Anyway, and they have an ISM version, and so I got a copy of ISM from them because we did a workshop with them last year. So anyway, if you've got some recommendations, it would be good to see how we might use a version of ISM to help us move perhaps an aspect of systems literacy work that we've been doing, or even within the systems engineering in COSI. I mean, are you going to, for example, the IW in January?
Well, that's kind of open right now. I'm not quite sure how that's going to work out. But what we are doing is we're going back, and with the software we have right now, is kind of multi-purpose. And so you can use it to do certain types of ISM activities. And you can also use it to develop the algorithm. That's what we've been doing, is we've been using it to test publicly available literature and to try to reproduce what has been published. So
okay,
there's a key aspect of the software that we have today that the other software components have that this one doesn't have. And that is the algorithm in the other existing software actually tells you which item to get information on next, which item to go collect empirical data on.
right.
Our software right now allows you to enter that, but it doesn't tell you, okay? And that is what we have used to develop the algorithms, because which data point to go get next essentially is the algorithm. So I've started this week on putting that automatic search process into the software. However, as I was talking with, you might have gathered we were talking with Kevin, is that you really need to determine which specific algorithm you're going to use. And I think this is a problem with the closed source software, and that is that, oh, you have an algorithm, but nobody knows what it is.
Right.
You don't really know if it's efficient.
Right.
And there's more than one algorithm.
Yeah, I think that's crucial. I mean, I think the whole issue of clarity and transparency in that respect is just absolutely vital, because otherwise it's just a black box. And I think the ability to explain precisely what's going on with the algorithm is a crucial part. I mean, one of the things that Janet and Michael and I have been talking about is the lack of real understanding about models in general. And this would be another example of how one could demonstrate modeling, if you will, in a very direct way by actually experiencing it. And the thought occurs, Janet, Michael, what might be useful for us to take some subset of any one of the number of different themes that we've been pursuing and actually use a variant of ISM that Joe would recommend to us, or even participate with us on it in a video kind of session like this, or so that we could do a screen share of the software. And actually, I don't know if that's a possibility, whether you would actually be willing to sort of talk us through an application.
Oh yes, I would be more than happy to do that. As a matter of fact, that dovetails quite nicely with what my plans are. And my plans are now that once we have these three fundamental algorithms, or three fundamental commands basically outlined is then to take those and put the automatic part in, take the algorithm development part out, and then create a type of software that can be used that's more like that has more like a standard interface to it. So I'd be more than happy to do that. In fact, I was hoping that some people would be interested in testing these out and working the individual types of applications once they've been moved out of, into a specific type of software package. Because the software package I have right now is fairly esoteric.
Yeah, okay. Well, then you'll just have to let us know when you want that. I'm more than willing to do that in any number of different domains that I'm working in on some subset. So, yeah, I'd be delighted to do that.
Well, maybe the best thing to do is, after this, we'll start a little email, Janet, and tell me who should be on the email, and then we'll just start documenting the requirements in the process, and so we can normalize expectations.
Right. So it would be Peter, the two of us, and Dwayne Hybertson at least, and then maybe others would be interested in joining. But I think this is really interesting. It's a subtle point, but it's so profound that if the process isn't transparent, then it doesn't matter how impressive one instance is of using ISM. It doesn't cause a sea change in the way people think about reasoning because they don't really understand what just happened.
Well, it's not reproducible. It's not scientific.
Yeah, right. And if they know that it's accessible to them, that they could understand the whole algorithm from end to end,
yeah,
it would be more of a revolution. And so, the proprietary character of the ISM software has really been an impediment to getting it broadly understood. And then the fact that the whole algorithm isn't transparent. I was going to ask you, Peter, did you met someone at, where was it, at GW or George Mason, who had worked with Warfield?
Well, no, I mean, I went to George Mason when I first came to Washington, which was in the late 80s, and sat down with definitely Aleko. I'm not sure if I think John Warfield was there. I think I met him once.
Who was that? The other one? Not Aleko, the other one?
John Warfield.
Oh, Warfield, okay.
Yeah.
But there was somebody at Caesar who in Huntsville who you introduced us to, right?
Gosh. I'd have to think about that.
Someone who said that Warfield had turned over the intellectual property rights to the ISM software to him?
Oh, that was a discussion about a colleague down at the University of Virginia.
Right, right.
Yeah, and I'd have to think about his name, but it was that was
someone we went yes. to that. We had a drink after the. Yes. I was trying to remember who that was, and Joe, I'm sure, knows him or knows about him.
Was it Bill? Oh God. Anyways, professor.
I'm not sure. There's a lot of players in the area, and it's and I've looked at a lot of people. I guess to sum up my view of the literature and the view of the processes is that the closed source approach to software modern implementation is definitely problematic. But when you go back and look at the 70s and the actual work that these folks were doing, they didn't have standard compilers, they didn't have standard computers. They were making this stuff up, handcrafting their own material, right? And so there's a body of knowledge there that you really have to look at and see what exactly they were saying. And there's a lot of conflict in those terms. My approach has been to look at that and then just to take it apart and then go all the way back to the logic, because that's where the fundamental piece is, the logic.
Right.
Go from an informal language, translate to a formal language, and do that in a way that helps everyone understand, that helps people understand and communicate. And so,
thinking about how important that is, especially for education, whether for young people or whatever age. Peter, do you think that this is something that the NSF would be interested in supporting?
Yes,
and Joe and Mary, would you be interested in getting NSF support for it? Excuse me. Because Peter has been talking to various people at the NSF about systems literacy and systems related ideas. And there is more interest now than there was a few years ago in branching out into that.
Oh yeah, I'd be more than happy to work with people to basically explore this area and to create fundamental, open types of approaches ubiquitously.
Right. Well, the issue for me has been, over the last 18 months, been in all of these conversations about systems literacy in a very broad definitional sense, but coming out of my own position with the geosciences, and I would love to use this software and this approach to deciding what in fact is important for someone to be systems literate, and it just would make a whole lot of sense, and so maybe we could get NSF support for that, or an aspect of it, or even to take as for example the ocean literacy, the earth science literacy, and the atmospheric literacy documents and come up with some kind of approach to designing and deciding what is important from a geosciences point of view, using what would geosciences literacy be like if one took those three areas. Anyway, so that's a practical sort of possibility that put out there.
Right, that would be using the software. And what just came out of you, what I was just thinking, listening to you talking with Joe, is that understanding the software is a key aspect of systems literacy. That and having it be open source and with transparent algorithms is a large part of what could be achieved in understanding the software. Now that. So I was thinking about the woman you were saying in the, what was it, computer education?
Yeah, absolutely. That would be a good idea. Yes, that would be a really interesting, particularly if we were developing a curriculum for students in schools around this. This would be really, because what you would be doing, you would be developing a curriculum and an approach for understanding decision making in groups. From philosophy to practice, and I think that would be within the context of STEM. I mean, it's a STEM plus C initiative, so looking at science, technology, engineering, and management, and mathematics, and computing. So maybe you actually specialize it in saying decision making in STEM using computers.
Well, I was picturing again it would be you said from philosophy to practice, philosophy to algorithms to practice.
Yes, of course.
That you would you'd want to have the curriculum. You'd want the students to understand everything that was going on from. You'd want them to get their hands dirty on the algorithms.
Yeah. That was implicit in my comment.
Okay. Because we keep switching over to using the software, and I'm thinking about.
No. I'm talking about going from the broad wonderful blue sky through your whole being, personhood, collection of contexts and prejudices and prior knowledge and everything else, through to understanding of the psychology of groups, to an appreciation of how logic structures get coded in algorithms, what those algorithms are doing, and then how you actually see them function in a computer program. And there may be levels of analysis or understanding of the computer coding,
Right.
depending on
And
the
then-
languages it's written in and how it's written, and whether or not, and that might be a subset for those that are interested in getting into, I don't know what you're writing it in, C++, Perl.
No, it's pretty accessible.
Okay.
I think.
Or isn't it
So,
MATLAB?
yeah, so-
I heard Kevin talking about, was it MATLAB? But
No, Kevin's
NetLogo.
doing this thing in NetLogo, but
NetLogo is very accessible too.
yeah, and all the stuff I've been doing here is JavaScript. It's just it's a
Okay.
serverless single-page app with JavaScript. Oh, you need a browser.
Right.
So the plan is to just make it very straightforward and standard modern JavaScript.
Fantastic. Okay, cool.
Yeah.
Yeah.
So
And NetLogo was originally developed for use by children. So
Yep.
it's
Okay, well then let's do this then. Let's start working on that. Let's write this up as a concept. Let's actually now I'll go and propose it to someone there, and
yeah, I think it's
and let's
perfect for
move
STEM.
ahead. Yeah.
Yeah. When you first
Okay.
mentioned the STEM plus C, I couldn't picture
No.
how to bring all of this together, but
No,
I think this is
this is it.
yeah.
okay, well we've
And-
got about 8 minutes left, so essentially I think we've got. I've got an action to actually write a little note to Peter, Janet, Michael, and Dwayne. Is that it?
Mm-hmm.
Yes.
Some type of project outline, so I'll do that after the meeting.
Wonderful.
We've got coming up in November 11th, we'll be talking with an open source community folks about the software itself, the Seagull Open Source Conference. And these folks are very freedom, and they're focused on freedom of choice. They're focused on democratic type of ideas, local community, co-ops, things like that. They're natural people to be able to be interested in this because they have the technical skills, they have the analytical type of approach. And so we're going to basically introduce them to these concepts and see if we can get some participation out of that community. The material from Huggins with a reference to Warfield's work will be incorporated into the talk. And essentially it's just going to try to bring together a group because there's a wide span of professions, there's a wide span of interests that are really necessary to effectively address the scope of the problem.
Yeah, absolutely. Can you put some links to some of that in the chat box or send it to us, please?
Yeah, there are
some links to the conference.
The conference and the Seagull community. Yeah, I'd be interested.
Yeah, it's what he has on the screen there.
That's what's on the screen, and that was sent out in the read ahead.
Oh, I see. Oh, I beg your pardon. Okay, I'll look for the read ahead. Okay.
And it's and also the links to Hogan's work in Psychology Today was basically I put those links in there also, and it talks and really freedom, intellectual, group intelligence, collective intelligence is really a.
Yeah. For some reason, I don't see it. Is that on the screen at the moment? I only see your voice and your face.
Yeah, screen sharing is what I'm doing.
Okay, I don't see it. I'll have a look.
Yeah, I can see
Okay,
it.
well,
I can see it. So it is in the read ahead.
yeah, I sent those, and the most interesting thing is the person that started the open source movement back in MIT, Richard Stallman, is a featured person in Psychology Today this month. So Software Freedom talks about the challenges of individuals and their online lives and how it's changing everything. So it's a topic of some current interest across a wide variety of folks.
Oh, Joe, are you and Mary affiliated with a university?
We are alumni from various universities, but we are.
But for the purposes of the NSF, I was wondering if Peter, would it help if there was, like if George Mobus, I wonder, would he be interested in participating? Bring in another academic person?
Well, sure. I think you should have all of the people that you need to achieve your goal.
Right.
You know George, and George would be, I think, would meet your criteria.
Right. Yeah, I was wondering if people who you've already communicated with, maybe you'll find more at the conference, who are this idea resonates with them already. So that I was wondering about, just collecting together a few principal investigators for an NSF proposal.
Well, I think that you should know more about that than I do.
Okay.
So,
okay.
My focus is going to be working with the open source community and working with people so we can actually reduce this to practice. The open source community, those people will have the algorithmic skills. They will have had that training. They will understand, what these specific components are. So they will need less build up or introduction to the technical parts. But then refine it with that group. Then we can move it to the groups that will need to have that part filled in. Right?
Okay. Well, this is what I was trying to picture. What we could rough in now with existing components, and maybe we should discuss this in an email. But Peter, I interrupted you there with your litany of how this could all come together, because once the group had used the software and understood what the software was doing, then that would reflect back into group learning, and then iterative changes to their collective intelligence. And yeah, I think it would just be such a clean core for a curriculum for STEM plus C. I think it's really good.
Well, we've got a couple minutes left, so I'm going to basically kind of recap here. Again, my action is to get the email out to you folks after this meeting. Then what I'll be working on the next few weeks is splitting out the source code and start developing specific applications now that focus on specific algorithms. And so there'll be a suite of web applications that, once you determine what the natural language relationship of interest is, of the natural language structuring relationship will guide you into selecting the menu pick list of which web app you'll use to continue forward. So we have a candidate 2 or 3 of those web apps right now. I think I can split out, maybe have 3 or 4 in the next few months, and we'll just kind of go forward from there.
Okay, thank you.
So thanks for your participation and interest. And
are we going to do a December meeting?
The December meeting, let's take a look at the December meeting, will be
December 3rd.
Okay.
December 3rd. Yep, December 3rd at 9 a.m. I will put some more information out. I'll probably also send out some detailed, a little bit of after action report on the conference on the 11th. A lot of people know what's going on and kind of go from there.
Great.
All right. Take care. Have fun.
Yeah.
Bye now.
Bye.
Thanks, Janet. Thanks, Peter.
Thanks.